For this problem, we're asked to calculate the moment about the origin of a force. We're given a force with I, J, and K components acting on a point A, and then we're given 3 different scenarios for position vectors. So we'll start by solving for scenario A. And for scenario A, our moment, of course, is going to be equal to the position vector crossed with the force. And we'll write that out. Okay, so our position vector is simply I, J, and K. So we've got 1 in the I column, 1 in the J column, 1 in the K column. Our force vector is minus 2I, minus 3J, and 5K. So to solve for this, basically, let's break it down. We'll do it the first time. We'll break it down carefully. So to solve for I, I'm going to have 1 in the J column, the 1 from the K column. We'll have the minus 3 and the 5. So that's our J component. Or rather, our I component. Our J component will be the 1, the minus 2, the 1, and the 5. And then our K component is going to be the 1, the minus 2, and the minus 3. So knowing that, now let's go ahead and do the math. So for I, we're going to have 1 times 5, or 5 minus 1 times 3, and that'll be plus 3. For J, we'll have 1 times 5 again, minus 1 times minus 2, or plus 2. And then for K, we'll have 1 times minus 3, so we'll have minus 3 minus 1 times minus 2, which will be plus 2. So we should have I 8, J 7, and minus 1K. So basically we have 8I minus 7J minus 1K. So that's the moment for moment about the origin for scenario A. For scenario B, let's write that out. So we have again I, J, and K. Okay, so for our position vector for scenario B, we have 4I, 6J, minus 10K. Our force vector remains the same, minus 2I, minus 3J, 5K. Our cross product will be, for I, we'll have 6 minus 10, minus 3, and 5. For our J component, we'll have 4 minus 2, minus 10, 5. And for K, we shall have 4, 6, minus 2, and minus 3. So for I, we'll have 5 times 6, or 30, minus 3 times minus 10, which is a positive number. So 30 minus 30. For J, we'll have 4 times 5, which is 20. 20 minus 2 times minus 10, which is positive 20. So 20 minus 20. And then for K, we'll have 4 times minus 3, so minus 12, minus 6 times minus 2, so a negative subtracted by negative minus a negative is going to be a plus 12. So this all cancels each other out. I have 0I minus 0J plus 0K. So our moment there is 0. All right, let's look at scenario C. So for scenario C, we have for our position vector, we have 4i, 3j, minus 5k. Again, the force vector remains the same, minus 2i, minus 3j, 5k. If I want to work this out, I have I, 3, minus 5, minus 3, 5, minus j, 4, minus 5, minus 2 and 5, plus k, and that will be 4, 3, minus 2, minus 3. That works out to I times 3 times 5 is 15. 15 minus 3 times minus 5. That gives me a plus 15, so 15 minus 15. Minus j, 4 times 5 is 20. 20 minus 2 times minus 5, which is a plus 10. So 20 minus 10 plus k times 4 times minus 3 is minus 12. Minus 12 minus 2 times 3, which actually is going to give us a plus 6. So we have 0i minus 10j plus, actually minus 6k. That will be our moment about 0. So it's going to be minus 10j minus 6k.